This video is going to focus on combining radicals. Now, there's a lot of flexibility when you're working with this, when you're working on combining radicals, and I'm just going to say, first and foremost, if you want to work with radicals or exponents, up to you. Doesn't matter. Just A, make sure you're consistent, and B, make sure to pay attention to directions. The only thing is that when you are combining two radical expressions, you can only add and subtract like radicals. And so those we talk about like radicals as having the same index and radicand. So some examples here. The first one, okay, what we need to do is first simplify, because right now you're looking at it like, okay, I can't add them. They're not like. The radicands, one is like negative 16x to the fourth, and then the other one is 2x. But you recognize also that the first one is not simplified. So maybe you can combine it after you simplify it. Okay, so let's simplify this first one. If we do that, we can recognize, okay, the negative can actually come outside the radical because we have an odd index radical. So we have the negative cube root of 16. Now 16 is 4 times 4, and each 4 can be broken down into a 2, so this would be the same as 2 to the 4th, x to the 4th, or, put it better, you can say this is 2x to the 4th power, right? We could distribute, okay? And then we have the 5x, and then there should be a times in here, times a cube root of 2x, okay? So I'm just going to keep working this down, all right? Now, remember when we're simplifying, we're trying to find that index appearing somewhere. So 4, well, I know 4 is 3 plus 1, so let's see if that helps us out at all. So this is going to be 2x to the 3 plus 1, okay, and then plus 5x times cube root 2x, okay, and then next, okay, this is going to be, all right, cube root, and then I have 2x to the 3rd power times 2x to the 1st power, and I'm just going to omit that, okay, plus 5x times cube root 2x, okay. And again, as always, I'm showing more work than maybe you need to, so don't feel like you need to show all this work. But now, again, using properties of radicals, I can break this up. This first factor here of 2x with a power or exponent of 3 on it, that would come outside, so I have minus 2x. And then the other one, unfortunately, stays underneath the radical, okay, and then plus 5x times cube root 2x, okay. So we have this, and now now I see, I'm looking at the radicals, or the radicands, I'm sorry. The radicands are the same, and the indices are the same, okay. So because of that, that's like saying I have a y at the end for both of these, so I can add them. They're going to be like terms. So all I have to do to add them is add the coefficients. So negative 2 plus 5 is 3x, and then times cube root 2x. Now, here, the reason, so I don't do anything with the x, and I don't do anything with the radical. Again, if you want to replace the radical with a y or something, that is perfectly fine. We think of that as a fixed object, and we treat it like any other variable expression, so we have to leave it the same. All right. For this next one, I want you to pause the video and see how far you get. Okay. Pause the video, try it on your own, see what you get. Okay, and what I think you get at the end is that you get to a point where you can combine two of the terms, but not all three. Okay, let's see. All right, so first of all, I'm going to represent 54 as 2 times 27, and I'm going to show less work this time. If you need to show more work, that is fine. And then, let's see, the x to the 7th, I'm going to represent that as x to the 6th, and then x. Okay, so then when I simplify this, I'm going to go a little bit faster here. The 27 is a perfect cube. When I simplify that, when I do the cube root of that, that ends up being a 3. So that would be coming outside the radical as a multiplication. And then I still have times the cube root of, okay, there's an x underneath there yet. I can't do anything with that. And then there's a 2, okay. This second, so that's kind of how the first term simplifies. The second term, all right, we have the 3, and then the x's sixth would come outside as x squared. And then, so we multiply, and then we have the cube root of 2, and then there's still this x hanging out. Okay, and, oh goodness, okay. The last term can simplify as, well, actually it can't simplify any further, it's already done. 5x squared times cube root 2x squared. Okay? So, what I think happens is something kind of unfortunate, but yeah, this first term, this first term and this second term, so I can express that as minus 3x squared times square root 2, or cube root 2x, I forgot the cube, and then plus 3x squared times cube root 2x, and then minus 5x squared times cube root 2x squared. Now, these first two can combine because the radicands are the same as are the indices, but the second term, well, that one I can't do anything with. Okay, that's just going to be hanging out. So, the first two combine, I have to take minus 3, add 3, 0. So the first two actually cancel each other out. And then we just end up with the 5x squared times cube root 2x squared hanging out at the end. And if you want for your final answer, just omit the 0 and you're done. Okay? So, I guess the big ideas here, combining radicals, make sure to look for like radicals. They have to have the same index and radicand. Okay? So just be on the lookout for that. And try this question in the quiz.